When it comes to solving absolute value inequalities that have a greater than sign in it, you're going to want to do the following. If it's the absolute value greater than a, some number, it needs to be changed to whatever's inside the absolute value less than negative a, and then what's inside greater than positive a. And if it's the absolute value greater than or equal to some number a, you need to change it to whatever's inside less than or equal to negative a and greater than or equal to positive a. So let's look at it in action. So absolute value of 3x is greater than 12, so it fits the first one perfectly. So we're going to set up two separate inequalities. 3x is less than negative 12, and 3x is greater than positive 12. And now we're going to solve each one individually. So I'm going to divide by 3 on both sides, and x is going to be less than negative 4. And I'll divide 3 on both sides, and x is going to be greater than positive 4. So I have my two inequalities, and as a graph, negative 4 and positive 4, since this is a less than sign, and it's going to the left forever, it's going to be parentheses going to the left forever, and this is a greater than, so it's going to be again a parentheses going to the right forever. So this is what our graph would look like, and in inequality notation, or interval notation, excuse me, it's going to be from negative infinity to negative 4, parentheses, union 4 to infinity. Next, we have absolute value of 2x is greater than or equal to 6. So again, absolute value is already by itself, so let's separate into two separate equations, or two separate inequalities. 2x is less than or equal to negative 6, and 2x is greater than or equal to positive 6, not negative, positive 6. So solve each one individually, divide by 2. X is going to be less than or equal to negative 3, and divide by 2 here. X is going to be greater than or equal to positive 3. So when I draw my graph, negative 3, then positive 3, this is less than or equal to negative 3, so this gets a bracket going to the left forever. And this is greater than or equal to positive 3, so it also gets a bracket over 3 going to the right forever. And in interval notation, since it goes to the left forever, negative infinity up to negative 3, which gets a bracket, union, and then a bracket again because of positive 3 to infinity. There's the answer for this one. Next, we have absolute of 3x plus 4 is greater than or equal to 2. Since the absolute value is by itself, we can just separate into two separate inequalities. So 3x plus 4 less than or equal to negative 2, and 3x plus 4 greater than or equal to positive 2. Now solve each one individually, so subtract 4 from both sides. Get 3x is less than or equal to negative 6. And then I'm going to divide by 3 on both sides. X is going to be less than or equal to negative 2. Same thing over here. Subtract 4 from both sides. 3x is greater than or equal to negative 2. And divide 3 on both sides. X is going to be greater than or equal to negative 2/3. And it's a fraction, but we're not overly worried about it. Don't have to compute anything, we're just going to put it in our graph. So negative 2 is smaller than negative 2/3, so we'll go put that first. Then negative 2/3 here. And we have a less than or equal to for negative 2, so that is a bracket going to the left forever. And we have a greater than or equal to for negative 2/3, so that is a bracket going to the right forever. And kind of separate it so it's a little bit easier to see. So there we have our graph, and our interval notation is going to be negative infinity up to negative 2 with a bracket, union again, and then another bracket, negative 2/3, going off to forever. There's the answer for this one. Last, we have negative 5 plus the absolute value of x minus 1 is greater than a half. This time we do not have the absolute value by itself, so we're going to get it by itself by adding 5 to both sides, and we're going to get the absolute value of x minus 1 is greater than, and if you take 1/2 and add it to 5, you're going to get 11 halves, but if you want to write as a decimal as 5.5, that's fine as well, whichever you prefer. But since we have fractions, I'm staying with fractions. Now I have my absolute value by itself, so I'm going to write out my two separate inequalities. X minus 1 less than negative 11 halves, and x minus 1 is greater than 11 halves. And I will solve each one on their own. So I'm going to add 1 to both sides, and when I do that, I'm going to get x is less than negative 9 halves, and I'll solve this one, add 1 to both sides, x is going to be greater than 13 halves. Again, we got fractions, we're not concerned with them, that's a-okay, because we're just plugging them into a graph. So negative 9 halves goes first, and then 13 halves goes second, and since this is less than negative 9 halves, it's going to be parentheses, going to the left forever, and this is greater than 13 halves, so again it's a parentheses going to the right forever. And finally, our interval notation for this, since it goes off to the left forever, is negative infinity up to negative 9 halves with a parentheses, union, and a parentheses for 13 halves off to infinity on the right side. And this is our answer for this inequality.